Hello everyone, I'm Natenael Maseresha. I'm an electrical and computer engineering graduate from Addis Ababa Institute of Technology. I am also a data engineering graduate from Gabay Academy. Today I'm going to present our project. Our project title is the analysis of possible factors leading to car accidents. The project is intended to analyze and calculate the effect of different factors leading to car accidents. These factors contain, for example, time, weather, weekday, season. These are the candidate factors we are going to calculate and analyze that leads to the car accidents. And eventually this project will try to provide a graphical visualization of our outcome or our results. So what initiates our project? The problem statement is it's a known fact that car accidents are the major cause of death around the whole world, and approximately 1.3 million people die each year due to the car accidents. This is the information from WHO websites. Although most accidents are human-driven, there are times that uncontrollable factors lead to car accidents. As I have said earlier, these factors are maybe it can be the weather, maybe it can be the number of traffics, maybe it can be the months or the seasons. So this analysis project is intended to study and analyze those factors and identify the most influential factor from those candidates. In order to minimize the rate of accidents, we need to understand why accidents happen. Not only why, we should also ask when do accidents happen, who is responsible for the accidents, where does the accidents happen more frequently. So the more information we gather about the accidents, the more we can reduce the accidents. The greatest challenge in building this project was we couldn't find enough data set for our country. Initially, this project was intended to provide analysis about Africa and especially Ethiopia, but we couldn't find a good and sound data set about our country. So this project is limited to only the developed countries. In this case, it's Canada. And another challenge was we couldn't find a powerful machine to run and process our data sets. So we used Azure virtual machines. Azure virtual machine provided us powerful machines so that we can process and change and load, also extract our data sets. These are the steps we followed to build our project. First, we collected the important tools that are useful for our project. The technical term for that is importing the basic libraries or the useful libraries. Second, we changed the comma-separated value data to a readable table. That is extraction in the technical term. Now we have the data, so we have to clean it. We have to remove unwanted data. We have to reduce null data or missing data. This is called the cleansing, data cleansing. So finally, we have a sound and useful data. We can continue to process the data, and that's called process and loading the data. The greatest success of this project was, the first one is we are very familiar with the programming language Python. Second, we know the basics of data engineering. Third, we are able to make use of Azure Cloud Services. As I've said earlier, we make use of Azure virtual machines, Azure Web App Services, Azure storage accounts or storage services. And finally, we are successfully able to predict the chance of accidents happening in a certain given data. For example, if I said what's the chance of accident happening in Wednesday, July of a cloudy season, our project will tell us the chance of accident happening on that specific date. That is the greatest success of our project. When it comes to the technologies we've used, on the top of all tools, we have Microsoft Azure services. We make use of the virtual machines, the storage accounts, and the web app services. And then we have a Python programming language. We use that to write all logics of the project. And besides Python, we have Pandas libraries. Pandas libraries let us to process the data and visualize the given data. And for the web app, we have used Microsoft Visual Studio Code to edit and write our codes. We have a PHP servers and PHP language to write the backend of the websites. And for the visible part of the website, we've used HTML, CSS, and Bootstrap. That's also known as the front end. And we are trying to improve the performance and the speed of our websites and our project. And finally, we try to include all other factors, for example, age, or the alcohol factors in the car accidents, the number of traffics in the car accidents. We try to include all these factors in the future work. Okay, now let's see our live demo of the project. Thank you for your attention. So now we're in our Azure portal. At first, we'll go to the virtual machines we've deployed earlier. This is a virtual machine, the data engineering virtual machine. We've deployed our project in that virtual machine. So we connect to the machine using remote desktop. We download this file and just connect to the remote desktop. Okay, now we are on our virtual machine. So we open this Visual Studio Code in order to edit our programs. Okay, first let me go through each folders in the project. This is Bootstrap. We've used it for the front end or the visual part of the website. And the data, we have collected the data sets for the Canadian car accidents. As you can see, it will take some time to load even if we're in the virtual machines. Imagine being on the local machine. Here are the data of the accidents. This is called the comma separated file. So we'll process this data in order to fit to our websites. This is the data process folder. We've used these programs in order to process the following data, and on the web folder we have our website project. So let's begin on the data processing. Okay, this is an interactive Python notebook. It provides a feature of running each cell separately. So let's begin with the importing the necessary libraries. We've imported pandas as PD. We've imported Seaborn. Those are useful for data visualization and data processing. Then we'll read our data. As you can see here, our data is located on the data folder. So we pass the URL of the data and we use the Panda libraries to read our data. Okay, now since it have finished deploying, let's see the final output of our website. The website we've built, as you can see, we've used the Bootstrap templates. So here is the dashboard. We can see records from 15 years, from 1999 to 2014. This is a gallery of our outputs. These are the visualized data from the data set. So let's click on one and go through each of them. Okay, this tab shows the average number of accidents through the years. So let's see by casualties. Here, the blue graph means there is no fatality, and the brown means at least one fatality have happened during the accidents. This shows us genders. So from the total accidents from our data sets, 43.5% of accidents are caused by female, whereas male are responsible for 56.5%. So now let's get back to the prediction part. So I will give our website some data. Let's say there is a female driver, so she will drive on March on, let's say, a clear and sunny day. and she planned to drive on Sunday. So when we click check, it provides a percentage of the chance of accident happening on that specific day. So there is 0.26% of chance accident on Sunday, Sunday of March, on a clear and sunny day. So according to our data, male cause a larger accident. So let's take the same data with the male driver, and it's in March. So the weather is a clear and sunny weather, and the day is on Sunday. So in theory, this percentage should go a little higher. So here it is. There is 0.34% of chance of accident for a male, whereas there is a 0.26% of chance of accident for a female. That's all about our project. Thank you very much.